Spanning tree protocol features can be categorized in two different ways. We have our performance features and we have our stability features. The performance features, such as uplink fast, backbone fast, and port fast, are all designed to improve the overall amount of time that is required for spanning tree protocol to transition its ports from the blocking state to the forwarding state and vice versa, to ensure that it doesn't take a total of 50 seconds or 30 seconds to make that transition happen. Notice here that some of these features, like uplink fast and backbone fast, are baked in to rapid spanning tree protocol. So you will not have to enable uplink fast or backbone fast with rapid spanning tree protocol. It's already part of the overall algorithm of rapid spanning tree protocol. However, if you're running 802.1d, uplink fast and backbone fast, you may want to consider. Port fast you'll want to use no matter what, because port fast allows you to take the access ports that go down to end stations and transition them directly to the forwarding state without having to go through the listening and learning states, which take up to 30 seconds. In addition to that, port fast is going to improve the sending of topology change notifications in your spanning tree topology by enabling port fast. If the port fast enable port transitions from down to up, back to down, back to up, those topology change notifications are not sent. They would be insignificant in that case. So port fast not only improves performance, but it's also going to reduce the amount of spanning tree BPDUs that are sent when things do change within the topology. When we look at our stability mechanisms, we have bridge protocol data unit guard, which is designed to make sure that if rogue BPDUs are received on an interface, that interface can be disabled, ensuring that a loop-free topology is maintained. We have BPDU filter, which is more or less a security mechanism, because by using BPDU filter, you can suppress the sending of BPDUs out of port. That way there, a user or a device out that port won't capture those BPDUs and then use them to analyze and determine what the overall spanning tree topology is. So BPDU filter works well on the periphery of your spanning tree topology on those ports that go down to end stations or on those ports that go to routers. Root guard, great little feature that's going to ensure that your root bridge doesn't change based on rogue BPDUs and rogue switches that are connected throughout the network. So it ensures that switches maintain their current root ports within the topology. And loop guard's a feature that's going to make sure that if you have an alternate port and it stops receiving BPDUs, it doesn't automatically go to the designated port state just because those BPDUs don't exist. It's quite possible that the BPDUs are missing because of a unidirectional link, meaning that spanning tree protocol has failed, or maybe the link itself is only sending traffic in one way. And if all of a sudden that link or that port transitions from the alternate port state to the designated port state, you now have a loop. So loop guard is preventing that transition from happening and causing the loop. How can we verify these different features? Well, there's two different ways. Some features can be enabled on an interface by interface basis, and other features can be enabled globally. If you want to verify the features that are enabled globally, you can use the show spanning tree summary totals command. So if we go out to our live environment on ASW1, we type in show spanning tree summary totals. We can see from this output that port fast by default on a global scale is disabled. BPDU guard is disabled. BPDU filter disabled. Loop guard disabled. Uplink fast, backbone fast, they're all disabled by default globally on the device. So if we want to enable it globally, we can do so. This is how we'd verify it. However, you can also enable these features on an interface by interface basis. And if you do so, the command to verify these features is show spanning tree interface, and then the interface type, and then the detail keyword added on to the end. So if we go back out to ASW1, We type in show spanning tree interface. And in this case, let's take a look at fast Ethernet 0/1. And don't forget the detail keyword. Your features would be listed in this area right down here. So if you have port fast enabled, it'll indicate it here. If you have BPD filter enabled, it'll be listed here. However, remember that they're only listed here if you enabled them on an interface by interface basis. If you enabled them globally, the information is listed here. So you really have to be aware of how you have been enabling these features on your device when it comes to verifying or troubleshooting them with the show commands.